Welcome back friends in one more video on measures of dispersion, and in this video lecture range and coefficient of range will be discussed. Two important features of a data set include the center of the data and the spread of the data. And the center can be measured in a number of ways, and the most popular of these are mean, mode and median. But in similar fashion, there are different ways to calculate how spread out the data set, such as absolute measures of dispersion like range, mean deviation, standard deviation, variance, quartile deviation or Lorentz curve, and relative measures of dispersion like coefficient of range, coefficient of mean deviation, coefficient of standard deviation, coefficient of quartile deviation and coefficient of variation. Among them, easiest and crudest measures of spread is called the range. Defining range. In statistics, the range is a measure of spread. It is the difference between the highest or the largest value and the lowest or smallest value in a data set. Or range is defined simply as the difference between the maximum and minimum observations. In case of group data, the range is the difference between the upper boundary of the highest class and the lower boundary of the lowest class. It can be also calculated by using the difference between the midpoints of highest class and the lowest class. It is the simplest measure of dispersion, and it gives a general idea about the total spread of the observation. Range can be calculated as range equal to L minus S, where L stands for largest value of the data set and S stands for smallest value of data set. Coefficient of range. This is a relative measure of dispersion and it is based on the value of the range. It is also called range coefficient of dispersion. It can be calculated as coefficient of range equal to L minus S upon L plus S, where L stands for largest value of the data set and S stands for smallest value of the data set. Practical utility of range. In all the measures of dispersion, it is simplest and fastest method. In a lot of cases, however, data is closely clustered, and if the number of observations is very large, then it can give a good sense of data distribution. For example, just consider a huge survey of IQ level of university students consisting of 10,000 students from different backgrounds. In this case, the range can be a useful tool to measure the dispersion of IQ value among university students. Sometimes we define range in such a way so as to eliminate the outliers and extreme points in the dataset. For example, the interquartile range, which will be covered in coming video. Here the outlier will not matter, and this definition takes the whole distribution of data into consideration and not just the maximum and minimum value. Here it should be pointed out that in spite of several limitations, the range can be a useful indication for many cases. As a student of statistics, you should understand what kind of data are best suited to define based on range. If there are too many outliers, it may not be a good idea. But range gives a quick and easy to estimate indication about the spread of data. It does not enjoy any prominent place in statistical theory, but it has its application and utility in quality control methods, which are used to maintain the quality of products produced in factories. The quality of product is to be kept within a certain range of values. And fluctuation in price like variation in money, rates, share value, gold price and exchange rates are commonly studied through range because the fluctuation in them are not very large. In fact, range as a measure of dispersion should be used when there are minor fluctuations. Last utility of range is in weather forecasting, where range gives an idea of a variation between minimum and maximum level of temperature. In fact, this information is of great concern to the general public because they are interested to know the variation in temperature on that particular day. The range also occurs in a box plot or box and whisker plot. Limitation of range. Range is quite a useful indication of how spread out of the data, but it has some serious limitation. The range is a very crude measurement of the spread of data because it is extremely sensitive to outliers. This is because sometimes data can have outliers that are widely off the other data point, and a single data value can greatly affect the value of the range. In these cases, the range might not give a true indication of spread of data. For example, consider the set of data 1, 2, 3, 4, 6, 7, 7, 8. The maximum value is here 8 and minimum is 1, and therefore the range is 7. Then consider the same data set only with the value 100 included. The range now becomes 100 minus 1, that is 99, wherein the addition of a single extra data point greatly affected the value of the range. And the next limitation is range cannot be calculated for open-end classes. Range is based on two extreme observations and it gives no weight to the central value or internal feature of the data. It is a poor measure of dispersion and does not give a good picture of overall spread of the observation with respect to the center of the observations. Let us consider three groups of data which have the same range. In all the three groups, the range is 50 minus 30, that is 20. In group A, there is a concentration of observation in the center. In group B, the observations are concentrated in the extreme corner. And in the group C, the observations are almost equally distributed in the intervals from 30 to 50. The range failed to explain difference in these three group dataset. This defect in range cannot be removed even if we calculate the coefficient of the range, which is a relative measure of dispersion. Calculation of range and coefficient of range. We will take some example, and in example 1, we have to find the range and the coefficient of range for this data. To solve this, first we have to find out the value of L, which is the largest value of data set, and that is 56 in this case. And then we will find out the smallest value of data, that is 22. And with the help of formula, we can calculate the range is 56 minus 22, that is 34. Whereas coefficient of range will be 56 minus 22 divided by 56 plus 22, and it will give us a value of 0.436. Similarly, in example 2, we have to find the range and coefficient of range for this data set. In this case, the largest value of data set is 205 and smallest value of data set is 95. Therefore, range will be 205 minus 95, that is 110, whereas the coefficient of range will be 205 minus 95 divided by 205 plus 95, and it will give us a value 0.367. Now let's take example 3, where we have to find the range and its coefficient of leaves per branch in the following data set. To solve this, again we have to find out the maximum number of leaves, that is 16, and minimum number of leaves, that is 8. There will be no effect of number of plant or frequency on range, and the range will be 16 minus 8, that is 8, and the coefficient of range will be 16 minus 8 divided by 16 plus 8, it will give 0.333 value. And in example 4, we have to calculate the range and coefficient of range of apples per branch in following data set. Here the maximum number of apples will be 34 and minimum number of apples will be 5. Therefore, the range will be 34 minus 5 is 29 and the coefficient of range will be 34 minus 5 divided by 34 plus 5 and it will give us value 0.659. Here also there will be no effect of frequency. Dear friends, thanks for watching this video on range and coefficient of range. In the next video, we will discuss mean deviation, which is one of the most important measures of dispersion. Till then, like and share this video, press the bell icon to subscribe my channel. Jai Hind, bye bye.